So let's look at another example of binomial distribution. We're just doing the same thing again. So I have an example of a card is cut and replaced from a deck of 10 different cards. So I have 10 different cards that are numbered 1 to 10. If a card is drawn 5 times and replaced, right? Calculate and graph the probability distribution for selecting a prime number. So here we have a situation where we have a prime number. We're gonna select, and a success is defined as selecting a prime number. So we can define it as success or failure, right? There's two possibilities. Either I get a prime number or I don't. So what are the prime numbers from 1 to 10? So we got to calculate the probability on a single trial of getting a prime number. So my prime numbers are 2, 3, 5, and 7. Okay, it's not 4, it's not 6, because 3 times 2 is 6. Anyway, it's not 8 or 9. The probability of selecting a prime number on a trial is 4 over 10, because I have 10 possibilities and a total of 4 possible ways to select a prime number. And the probability of not selecting a prime number on a trial is 6 out of 10. So for every trial, right, using the formula, probability of x, and we're going to define it as number of successes. X is our random variable, and number of successes is going to be our what our random variable is going to represent. And it's n, number of trials, and choose number of successes, times the probability of success to the power of number of successes, multiplied by the probability of failure to the power of number of failures. Okay, so we already calculated the probability of success. It's 4 out of 10. And actually, we already calculated Q, which is the probability of failure. But just so that you know, it's the complement of P, which is 6 over 10, 1 minus 4 over 10. Right? If it's not a success, it's a failure. That's just what Q means. And N is 5 because we have 5 total trials. And our random variable, X, is going to be number of successes. So I can choose 5 cards and get 0 prime. I can get 2 prime. I can get 1 prime, 2 prime, 3 prime, 4 prime, or 5, all 5 primes. And what is the probability of that happening? So we can use our formula for each random variable. So probability of selecting prime 0 times. We have 5 choose 0, right? Probability of success, 4 to the power of 10 to the power of 0, right? Times 6 to the power of 10 to the power of 5. And probability of selecting 1 prime, 5 choose 1, right? Times probability of success to the power of 1. Probability of failure to the power of 4, right? Number of failures. So probability of 2 primes. So two successes, right? Times the probability of success, 3 failures times the probability of failure. And that's actually 5 choose 2, right? 5 choose 2 over right there. Okay, and this is probability of selecting it 3 times. It's 5 choose 3, 4 to the power of 10 to the power of 3, 6 over 10 to the power of 2, number of failures, number of successes, probability of success, probability of failure. All right, and this is 5 choose 4. Sorry about that. And it's probability of success, 4 successes, 1 failure. And then finally, selecting prime 5 times. 5, choose 0 paths to success of 5 times. And then 4 to the power of 10. 4 over 10, probability of success to the power of 5, multiplied by probability of failure to the power of 0. Okay, so we calculate these values, and we end up getting like 7% here, almost 8%, 26% here, 34%, 23%, about 7%, and 1% of selecting prime 5 times. And if we were to graph these values, it's just like put our number of successes here, the probability over here, and the probability of getting it 0 times is about less than 1%. Or sorry, what would I say? Yeah, 7% or 8% right here. Probability of getting it 2 times is just under 35%, etc., etc. So we just graph these values against number of successes and the expected value. If I select card 5 times, how many prime numbers can I expect to get? And we just use the formula. EX equals NP, number of trials, 5, times the probability of success, 4 over 10, which is equal to 2, right? So if I select a card 5 times, I can expect to pick prime number 2 times. So if I repeated this trial an infinite amount of time, I might get 5 sometimes, I might get 0 sometimes, I might get 2 sometimes. But if I averaged all the outcomes, I would get an average of 2 times successes. And that's it.